Okay, guys, welcome back to another lesson. Okay, we're still in this kind of linear algebra realm with matrices. Today we're going to talk about what we call this is determinants. Okay, this is just for a high school class, so we're not really going to go in depth. What truly is a determinant? How does that translate? With other different topics. I'd love to, but it's a little bit over the scope for a high school class right now. Okay. So I do apologize in advance where you're not going to get too much of a background with it, but you'll at least know what a determinant is and how to calculate it, okay? So let's go ahead and talk about what a determinant is. So this is called a second order determinant, okay? We're just looking for a 2 by 2 matrix right now. And to find the determinant of this matrix, you multiply the diagonals and you subtract the outcome. So for instance, I multiply this diagonal and then subtract the multiplication of this diagonal, okay? And that number will represent that matrix, okay? Right now, that's the key part, is how do we represent this matrix? If I wanted to give it an identity in a way, it's by this determinant. So for this example, 4 times 6 is here, 5 times negative 3 over here. We're going to subtract the result, and we get 39. Okay, so let's go ahead and do that. So here's our first matrix, and we want to find its determinant. Okay, so to do that, we're going to go ahead and use that multiplication method that we were looking at here. Okay, I'm going to take this first diagonal, multiply it, I get a 0, minus, I'm going to take this diagonal, do the same thing, multiply it, so I get what, negative 4? I'm subtracting a negative 4, it's like I'm adding it, so my answer is going to be 4. Okay, so the determinant, it's going to be a 4 for that guy. Now, I don't know if you caught this yet. You see how I don't have brackets around this? Typically, I would have brackets, right? It would look like this. But I didn't. I switched them out for what looks like absolute value signs. All right. If you ever see that switch, that is telling you they're looking for the determinant. All right. So a little bit of a notation change when it comes to this guy. Okay. Let's do the next one. Find the value of this determinant. So here's my matrix. I know I'm trying to find the determinant because of the lines here. So I'm going to do the same thing. I'm going to multiply these two guys together. I get a 0. Multiply these two guys together, I get a 2. So if I subtract both of them, I get that the determinant is going to be negative 2 for this matrix. So option A would be the correct answer. Okay? And once again, it's hard to not get into the details. I really do want to, but I'm trying to keep this as simplistic as I can. This number is just representing the matrix. We're going to use this number to figure out an inverse. We'll do that in the next lesson, okay? But for right now, we just need to know how to calculate. Now, what if I translate this into a 3 by 3 matrix? A little bit bigger. Can we really just multiply the diagonals? And the answer is no, okay? We can actually do it by expansion of cofactors, or we can use this diagonal rule for it. I'm going to show you both of them, okay? So step 1 is rewrite the first 2 columns to the right of the determinant. Draw your diagonals, beginning what we did before, upper left to the right. Okay, multiply all those guys together. And then you're going to subtract by doing the same process with the other side. And go ahead and multiply those diagonals. Okay? So we're going to find the sum of each products and then subtract after as the result. All right? So if you're a person, and I highly recommend to write down these steps, it makes it a lot easier to see what you were doing. Here we go. Okay, here's our first problem. So here's a nice little 3 by 3 matrix, and we're just going to find the determinant of this guy. Okay, and like I said, I'm going to do this 2 different methods just to show you the expansion by cofactors is probably better for you to know, but for right now, like I said, for high school, I think this isn't too bad. So we're going to take this guy, and our first step, okay, is to take these first 2 columns and write them over here. So 3, 2, 1, negative 2, negative 1, 2. Okay, see how I just rewrote those? Okay. Now, should I use a different color? Why not? You guys like pink? Should I pink out? Okay. So here's what we're going to do. We're going to take each diagonal, starting here, and we're going to multiply them together. Okay, so 3 times -1 times -3. That gives me what? A positive 9. Plus, we're going to go ahead and add the next diagonal. So these guys come together. So -2 times 0, I'm done, it's 0. Anything times 0 is 0, so that makes it easier. And the last column over here, we'll multiply those. So 2 times 2 is 4 times a -1, which gives you -4. Okay? So we're going to add those guys up, and we're going to subtract the other diagonals. So pink didn't show up too well, did it? Try green. So now we're going to start over here. Okay, we're going to multiply that diagonal together. Okay? So 3 times 2 is 6 times 2 is 12. We have 2 negatives, so it becomes a positive 12. Okay, let's multiply these guys together next. So we have a 0 involved, so no matter what, it's going to be a 0. The last diagonal is all 1s, but we have 2 negative 1s, so that just becomes a positive 1 there. Okay? So if you like to color, if you're into highlighting, this is the perfect problem for you. So this guy becomes a 5 minus, this guy becomes what, 13? Okay, so the determinant, and I should write that down, I apologize. So the determinant is equal to 5 minus 13. So for my final answer, I give what? -8. That's my determinant for this guy. And that's what you do. Okay, so you take these two columns, put them over here. Then just like 2x2s, you take your diagonals and multiply them, add them together. Take the other diagonals in the opposite direction, multiply them, add them together, and then subtract what you have here. Okay. Now, let's change it. Okay, what I'm going to do, you're going to ignore this. That's a different lesson. In fact, that's our previous lesson. Do we have time? Yeah, I got time. I have class actually coming up here, so I'm hoping I can fit this video in place. All right, so what we can do is we can use cofactors, expansion of this. So what does that mean? Well, let me just rewrite this matrix. So this is another method for finding the determinant. Okay, it takes a little bit more time, but it still comes up with the same result. So here's the deal. What I can do, okay, and we're going to start with any row we like. Just depends. I'm going to pick this first row. Okay, and what I'm going to do is I'm going to put a positive, a negative, and a positive here. And this is why I don't like using. I hate doing this whole lesson to begin with. Not because I don't like determinants. That's not the case. I love this whole entire topic. It's because I can't really fully explain everything without getting into the details of it. So I do apologize for that. So what this is telling me is, let's say I chose 3. Okay, so I'm going to find the determinant. So I'm going to start with 3. And then I'm going to block out this column and this row. And when I do that, I have these 4 numbers left. That's like a mini determinant I'm trying to figure out here. Okay, does that make sense? So I pick a row that I'd like. To be honest with you, pick the first row. It'd be the easiest to start with for right now. Usually you'd like to pick a row with 0, but for right now, for our instruction, let's just say you pick the first row. Okay, and then you block out the rest of the row and column that it goes with, and then what's left is this guy. Now, I'm going to make sure that this first one's positive. The next little determinant I come up with is a negative. So now I'll go to this guy. So I'm going to pick -2 here. Okay. So once again, I'm going to block this row out, and now I'm blocking this column out. So what 4 numbers are left? 2, 0, 1, and -3. just like that. Okay, and the last one is a positive. And I'm going to put a negative 1, right? That's the last element right here. What's the mini determinant here? Well, here's negative 1. I block out this row and this column, so I'm left with just what? I'm sorry, this column and this row. I'm left with those 4 numbers here. 2, negative 1, 1, and 2. Okay? So, looking at this, I'm now going to solve each one individually for its determinant and go from there. So, let's look at this one here. I have a 3 times, what's the determinant of this matrix? Well, multiply the diagonals. Negative 1 times negative 3 is 3, minus 0. Okay. So, if I'm subtracting a negative 2 to this guy, let me just keep it there for right now. We'll get back to it. I just want to keep the negative there. So now let's find the determinant of this guy. So 2 times negative 3 is negative 6, minus 0. And then plus a negative 1. Then what's the determinant of this guy? It'd be 4 minus a negative 1. Would you look at all of those negatives? Oh, that's a lot. Okay, let's simplify this guy. This is what? Just 3 times 3, which is 9. This is just a negative 6, right? Times negative 2 is 12. So we're going to subtract a 12. See how I only worried about this. There's a lot of negatives going here. So I just messed with this. This is negative 6 times negative 2 is 12. And then pull the subtraction sign down. Then over here we have, what, 5 times a negative 1. So we're going to add a negative 5 to the mix. Add these guys up together, we get negative 8. So let me just write down determinant equals, and it's going to be negative 8 for that guy. Did we get the same answer? Absolutely. This one's a little bit more in steps, and there's some negatives involved. Okay? So it's there. Now, if you chose a different row, let's say you chose this row instead, you do the same process, except now these are the signs you're going to work with. If you chose the third row and you're expanding it, these are the signs that you're going to use for that process. So it just depends on what row you're in. That will depend on the signs here for these guys. Okay? All right. So I just wanted to show one example of what it looks like when I use code factors here. I'll let you use either one. I think this one's a little bit easier. Now this only works for a 3x3, so you do have to be cautious with that as well. Okay. Let's try another example out. Okay. So let's see. We have 2, 5, 1, negative 3, 0, 2, negative 1, negative 2, and 5. Okay. We want to find the determinant of this 3x3. So first step, take the 2 columns, add them. The outside here. Not the third column. Don't you dare take that third column out. Just these 2. That's all you get. Now we just do the diagonals, right? So let's take this diagonal here. We get 0. Add the next diagonal. Okay, what do we get here? Negative 3 times negative 2 is 6. Times 1 is still 6. And then, oops, let me write this down like this so it's a little better. The final diagonal, 5 times 2 is 10. Negative 1 gives me negative 10. Okay? All right, now let's go the other direction. So from here, I get 5 times 5, which is 25, times a negative 3 is negative 75. This one, 2 times 2 times 2, which is what, 8, with a negative there, so it's a negative 8. And this one's 0, because there's a 0 involved. So if I multiply them all by a 0, we're done. Okay. All right, now we simplify. So this becomes what? Negative 4. And then over here, we get what? A negative 83? For that guy there. I love asking you questions when you really can't tell me. So it'd be negative 4 plus an 83, right? So we get what, 79 for that guy? That'd be my determinant of this matrix. Okay. And if you would, if you did it by cofactors, you would get 79 as well. Okay. All right. Fun stuff. It is to me. I mean, I like doing this stuff. I do apologize because, like I said, right now you're not having much context with this, which sucks. But at least know what a determinant is, like how to calculate it. That's the important part of this. Okay, final thing. You could also find what's called the area of a triangle with a determinant, believe it or not. So what you do, we have these points here that make up the triangle. Remember from solving a system, the first column are your x's, your second column are your y's. So look at the points here. We have negative 4 and 3. So negative 4 is the x, okay? 3 is the y. I'm sorry, yeah, 3 is the y. I was looking at the wrong one, sorry. See how that kind of coincides here? We have 3 and 1, 3 and 1, negative 2, negative 2. Now notice this last column represents z's, okay, in a way. It's like the z column. Is there any z's in my graph here? No, we're only graphing this in 2 dimensions, but you still just put ones there as sort of like a placeholder. Okay, that's what you're going to do for that guy. So you take your determinant of this and take half of it. That'll give you the area of this triangle. Okay, which is pretty cool. It's a little bit easier than what? Find the distance between these guys, especially if you don't have 2 of the lines being perpendicular. That could be a little bit more work. This could be less. Okay, so let's go ahead and do an example together. So let's say a surveying crew locates 3 points on a map that formed the vertices of a triangular area. Okay, a coordinate grid in which 1 unit equals 10 miles is placed over a map. So the vertices are located at the following points. Use a determinant to find the area of this triangle. Okay, so area is equal to half of the determinant of what we got here. So that's going to be what? 0, negative 1, negative 2, negative 6, 3, negative 2. And then, like I said, the last column looks like a placeholder in a way. They're all ones there. All right, see how I did that? See how the x, y, x, y, x, y. I just took the points and put them in a matrix that we're going to find its determinant. So now we take these 2 columns, we tack it on, okay, and now we're going to find we're going to find the determinant. This half, don't worry about it. It's just hanging out, it's having fun. We'll multiply by the half at the very end, okay? But just don't forget it. All right, so now let's go ahead and go through the diagonals. So this first one's just a 0, right? Because 0 is being multiplied to everything there. This next diagonal is a 3, but it's going to be a negative 3. Sorry, let me put everything here. And the last one, which, oh, there we go. Boom. We get negative 2, which is a positive 4 right there. I know, multiplied by 1 still gives me the 4. Okay, the other direction, boom. So that's going to be a positive 2, right? Negative 2 times negative 1. Okay, next one has 0 involved, so we're just adding 0. The last one, we have 3 times 1 is 1, or 3, and then times negative 6 is negative 18. Okay, so this guy here, we're going to simplify first. We get a 1. And then over here, we get a negative 16. So 1 minus a negative 16 gives me 17 for that guy. Okay. Now we're not done yet. This half that I said forget about it, you can't forget about it. You got to bring it back. So to find the area, you take half of your determinant. So the area is going to be, what, 8.5 square units? Now here's the deal. Okay, that's just its measurement on the map. Okay, let's think about this for a second. On a coordinate grid, 1 unit equals 10 miles. Okay, so we can use that. So if 1 unit is 10 miles, okay, how can I figure out the area of this triangle here? Well, let's think about it. 1 square unit is going to be, what, 100 miles? If I just square that result. So my area is 8.5 times 100. Okay. Typically, you wouldn't go further than this, but since they gave us a little bit of a unit conversion, we can do that. Does that make sense? So we get 850 square miles for this triangle that's in this ocean. I said triangle and ocean. There's no triangle or ocean in here. No bother. Well, let's say it was. All right. So there's my final answer for that guy. All right. Oh, what do you think? Do one more? Yeah, let's do one more. One more. Okay. So let's find the area of this triangle. Okay. Now, notice, did they give me a unit conversion, like 1 unit is 10 miles or something like that? No. So I don't have to do what I did last time. So I'm going to take those coordinates, I'm going to plug them into my little determinant here. Uh-oh, we got zeros. We like zeros. Zeros is less calculation. Okay, take these guys, write them over here. Right? Just like that. Okay, first let's find the determinant, then we'll multiply our answer by 1/2. So let's take this guy. Boom. 2 times 2 is 4, times 1 is still 4. Next one. Boom, that's a 0. Boom, multiply by 0 again. Makes it easier, so we're done with those. Let's go the other direction. 3 times -2 is -6, times 1 is still -6. Next diagonal is 0. Next diagonal is 0. Hallelujah, hallelujah. Okay, next step, add. So this is 4. Minus, this becomes -6. So my determinant becomes what? What's 4 minus -6? 10. Typically we'd stop there, but to find the area, all I have to do is take 1/2 of my determinant. So if I take 1/2 of 10, I get 5 square units as the area of that triangle. Okay? That's it, guys. So honestly, if your triangle didn't have a set of perpendicular sides, you have to do some distance formula stuff, and then you have to try to find a way to essentially you have to find the altitude. And you might have to do a little Pythagorean theorem. So there could be some extra work involved. This is kind of going away from it. It's like, hey, just give me the coordinates, and we can calculate the area just finding the determinant, which is pretty cool. Okay? That's it, guys. All right, that's determinants. If you have questions, just let me know. And like I said, I apologize. I don't know. Maybe I'll do a video doing a more in-depth of what a determinant is. But for a high school class, it's not quite worth it. It really isn't. So we'll just go from there. But hey, hope you're doing well. Have a good day, guys, and I will see you in the next lesson.